So my name is Arun Gupta. I work for Red Hat. I am the director for developer advocacy. I was part of the founding team for J2EE at Sun. That's where I joined. J2EE 1.2, 3, 4, Java EE 5, 6, 7. So I've seen lots of releases. I've been involved in each one of them since the very beginning. For Java EE7, I was responsible for driving the launch of Java EE7. So working with people like you, who care about the Java EE7 technology. So now I work for Red Hat, and developer advocacy really means meeting brilliant engineers like you around the world, understanding how you use our technology, and taking that feedback back to our engineering team to make it all the more better, and also becoming your advocate at Red Hat, and vice versa. Showing you how to best utilize our technologies, whether it's technology or a product, either way. So the idea is we create the bridge. Me and my team create the bridge between the developers outside and the engineering team and the product management team inside Red Hat. So today, the goal is going to be to talk about Java EE7. How many of you are already using Java EE7? That's OK. Raise big hand if you are. That's all right. Cool. How many of you are using Java EE6 today? Sweet. All right. Anybody on Java EE5? OK, rest of the hands are Java EE5. Cool. Anybody on J2EE4, 1.4? All right. Yay, we got a winner. Excellent. So, well, today the goal is talk about Java EE7 and definitely keep the session interactive. I've given presentations to much bigger audience, and I can very easily handle the interaction. Any point of time, interrupt, say, I don't get this, or how about this? Don't hold on your thought. Let it go. So what I'm showing you here is a GitHub project. This is Java EE-samples organization. So if I look at it here. In the Java EE samples organization, there are lots of different Java EE technologies related samples. Samples, hands-on labs, proof of concept, end-to-end applications, things like that. So the one that I'm highlighting today is Java EE7 samples. These are about 200 plus samples/tests that are contributed by the community members from all around the world. And you can see up here, 36 contributors. So a lot of people are actually actively working on this. So what they do is, in Java EE7, there are a lot of technologies that were added. So if you look at, say, for example, WebSocket, it's a fun technology. If you want to understand how to build WebSocket applications in Java EE7, you click on this link over here, and you deep dive. You can see there are about 30-odd samples just on WebSocket, helping you understand the API and what works and how does it work. You want to understand what is CDI and how does it work in Java EE7. So there you go. You got about 25 plus samples on that. And each of these are hello world samples. They're not like big application. They're very simple hello world samples focusing on a particular API or a particular feature of the technology. That's the goal over here. Okay, so they're all around that. They're not only samples, but they also show you how to test that particular feature. How many of you are familiar with Arquillian? All right, that's pretty cool. I like that. So Arquillian is think of it as a framework which allows you, a testing tool rather. It's an integration testing tool which takes your unit testing to the next level, where you want to do integration testing of your application across different components with multiple application servers in a container agnostic way. So let's say you build a Java EE application. You want to test it on Wildfly, JBoss, WebLogic, WebSphere, Glassfish, all of those servers. So you can say, in your POM XML, you use Maven, right? Yes. OK, that's good. That's good. Now, I've been to places where the build environment is, we right-click in Eclipse and export the WAR file. There is no Maven there, no and, nothing. So if you use Maven, then it's more like building a profile. Say, what? Run this profile. It's going to test against Wildfly. Run this profile. It's going to test with JBoss EAP. Run this profile. It's going to test against different app servers. So it really allows you to test your application, completely do your continuous delivery, continuous integration using Jenkins very easily. So each of these samples, they also show you how easy it is to test that technology using Arquillian. Okay? So the code is all available, github.com/javaee-samples. In there is Java EE7-sample, so you can clone it, fork it, play with it, send a commit, whatever it is. We'd love contribution. So here I have, it's a massive Maven project. So I've opened it in NetBeans. NetBeans, just because I've been more used to it. You can definitely use IntelliJ. IntelliJ provides very good support for Java EE7. And of course, Eclipse. We have JBoss Developer Studio, which provides comprehensive support for Java EE7. Not only that, it provides, typical the problem with Eclipse is plugin hunting. You go figure out which plugin works, and when you actually download the plugin, it doesn't work. So with JBoss Developer Studio, we provide you a little bit more seamless experience. We say you download JBoss Developer Studio, all the plugins that are known to work with the exact version are packaged together. And so you can open up this project over there as well and play with it. But I just feel more comfortable with NetBeans. So here you go. We got lots of Java EE7 samples here. Let's start with WebSocket first. Now, HTTP was designed for just sharing information on a network, on ARPANET basically. Go back 50 years ago or so. So that's how it was designed. But today, the kind of data exchange that's happening, that's like they never thought of this data exchange to happen today. So the limitations that are coming out of HTTP are, for example, first of all is client initiated. That only client sends a request to HTTP server, which then processes it, generates a response. There is nothing that a server can send to client. There are hacks like long polling, and stuff like that. But think about how many of those long polling requests are actually waste. Or think about how many of those polling requests are actually just pinging and then closing the connection and opening it again. So there is no clear way for server to explicitly send data to the client. So that's one, is client initiated. Second, for every HTTP request, a new TCP connection is initiated. Once you receive the response, the TCP connection goes away. New request, new TCP. Okay, so that's another one. Third problem with HTTP is it's a very chatty protocol. So if you want to send hello world, which is like 11 bytes, for that hello world, you are sending literally 650 characters back and forth in terms of HTTP headers. So that's a lot of garbage going in for that just 11 bytes of hello world. I mean, your payload is generally bigger, but that's still a lot of headers. It's okay if you have a few messages coming per second, but the moment you get into 1,000 and 100,000 messages, that model doesn't scale because you have to do the HTTP header generation, processing, all of that. So in summary, it's a client-originated protocol running on multiple TCP connections and a very chatty protocol. So that's exactly what WebSocket tries to solve. So what is WebSocket? My one-line definition for WebSocket is it's a full duplex bidirectional communication channel over a single TCP connection. So what that means is it's bidirectional. That means client can talk to server, server can talk to client. One. Second is full duplex. That means they can both talk to each other, waiting for the other party to say, oh, you send a request, then I respond, or no. Client has to send a message to server. Server can send a message to client independent of that. So it's full duplex. And the best part is you start with a simple HTTP request, and then you upgrade that to a WebSocket connection using standard HTTP upgrade terminology, which is defined in the HTTP RFC itself. So you upgrade that to WebSocket, and once it's there, it's a WebSocket connection. There is nothing HTTP about it. So think of WebSocket as opening a raw socket on the web over port 80 or 8080, whatever your HTTP port is, and then doing client and server exchanging infinite amount of data, hypothetically at least, between them, unless one of them says, OK, I don't want to talk anymore, and let's close down the connection. So it's an explicit request by either client or server to terminate the connection. Okay? Let's see how we build that kind of an application. Sounds pretty complex. You don't need to know all those details in order to build the application. But I always lift the hood and look under the details, what's happening under the hood. So here is my canonical chat server. How would I build a chat server? So if you look at it, it's my public class chat endpoint on line 13. If in order to convert that into a WebSocket endpoint, I just put the add server endpoint annotation. Just that one line, and that becomes a WebSocket endpoint. I need to specify the URI where this WebSocket endpoint is listening. So I do that by specifying /chat. Okay. Now a WebSocket endpoint can communicate, a server endpoint can communicate using text and binary data. So in order to do that, you say, okay, you know what, I receive text data now, what do? I dispatch to a business method where I can do some business logic over there. So then you say, okay, string parameter, give me the business data here, or give me the payload here, and this session provides a conversation between the client and the server. Now think of it as a chat server. So what you do is there's a client which sends the data to the server. There are other clients connected to it as well. They all send data to the server, and it broadcasts it back to them. So it's like a classic wheel model. So there's a hub, and the clients are on the edge of the wheel, on the spokes. So client sends a data, server receives it, and then it broadcasts to other. Remember, WebSocket is a very low-level protocol, so any and everything you have to build on top of it. So if you want to build a client-to-client peer mechanism, it still has to go through server. But then you can start sending client ID and things like that as part of your communication, and then the server mediates and enables that peer-to-peer communication for you. So in this case, I'm saying client, give me all the open sessions as part of on this server, and then I'm saying from the peer that I'm getting, just broadcast a message. So very simple server, chat server. Now in order to do a WebSocket connection, you need to specify a ws://URI or //URI scheme. So here, that's specified over here. You say host port and the URL, which is chat for us. And then this is a JavaScript API by which you open a WebSocket connection to the endpoint. Okay, this is how you open it. And remember, we talked about HTTP upgrade. From the browser, when you say new WebSocket, it automatically does the HTTP upgrade for you. You're not required to do that. Browser and operating system and networking layer takes care of all those details for you. But it's good to understand what's really happening behind the scenes. There are user callbacks or callback methods on WebSocket API, on open, on message, on error. And this is my communication API, websocket.send. So very simple, very trivial JavaScript API, which allows you to do a lot of fun things on it. Okay, so that's sort of my very trivial chat client server sort of. It's a very dumb client. There's not a fancy user interface, but it works. Okay, so let me show you a different sample then. So what I'm doing is I'm firing up my Wildfly application server. Wildfly is Java EE7 compliant application server, what used to be JBoss AS. Our story is JBoss AS. JBoss is a much bigger brand name. It is like JBoss has a lot of other offerings. Data virtualization, Fuse. I won't go into all those, but the point is, in general, at Red Hat, if something has a cool name, is community. If something has a boring, like Red Hat, JBoss, blah, blah, that's a product. That makes money for us, but the name is boring, which is OK. So something like Wildfly is a pretty cool name. I got stickers. I can give you stickers for that. So Wildfly is a cool name, and that's a community project. And the way the community project is converted into the product is, at any given point of time, like today is Wildfly 8.1 available. 9 alpha was released yesterday. So eventually, at one particular version of Wildfly, we'll pick, so we're going to productize it. And really, the code is going to be 99.9% similar. All we do is JDK certification, database certification, operating system certification, and things like that. And we do that, and that's it. If we find a bug, then we fix it, and then it gets integrated back into the upstream version as well. So you start with Wildfly today if you want to do Java EE7 development. You deploy your applications over there, and when the commercial version is available and you want to run it for your customers, you just switch to the commercial edition. And the plan today is EAP7 will be released next year. So just to kind of get your feel ready. Okay, so here is my Wildfly up and ready. Now I'm going to open up incognito window here. Okay, open up another one here. And I'm going to open up my whiteboard application, which is apparently already pre-deployed over there. Okay. All right. So here I am. I click around this whiteboard. Whatever I do on this whiteboard is automatically reflected on the other whiteboard. I can change the shape or the color, and that happens as well. I can say, I'm not in an online mode now. I'm going to click around, and that data transfer doesn't happen. But then I can say, you're out of sync. Let me make you in sync. So think of it as a multiplayer game built on the web using HTML5, WebSocket, Wildfly, all those cool technologies together. And this is just raw HTML, no, nothing fancy, just raw HTML5, canvas, etc. So what's happening here on the hood? Okay, let's take a look first. So let's refresh this puppy here once again. So I'm going to look at network. I'm going to filter, and I only want WebSockets here. I look at WebSockets only. Then I say, show me the WebSocket here. Now, under the wire, the way WebSocket work is exchanges WebSocket frames. That's the terminology which is defined in the WebSocket protocol itself. So Chrome Developer Tools allows me to introspect the frames. I look at the frames here. So let me refresh this page also for a second. Now I start sending the data again. I go here and I refresh it, basically. That's the Chrome way of refreshing it, apparently. Ugly, I know, but that's what it is. You tend to work around your bugs sometimes. So what's happening is, wherever I'm clicking, is saying, oh, shape square, color red, coordinates x and y. It puts that into a JSON structure. So anywhere I'm clicking is capturing that JSON structure. These are both client endpoints registered to a WebSocket endpoint, is capturing that JSON structure, sending it over the wire. The server receives it, and it says, let me see which all clients are listening, and send this JSON structure to them. They get it, and they refresh themselves. So that's basically the WebSocket under the hood. And then when I say send snapshot, it says, oh, let me take a snapshot of the HTML5 canvas, and then do the binary communication instead this time, instead of saying text JSON structure. So for example, if I do here, say send snapshot. Now if I look at it here, it says binary frame, so opcode 2. Opcode 2 is a WebSocket language where it says this is a binary frame, basically. And of course, it doesn't display the content of the binary frame in developer tools. So let's look at the code behind this now. So this is my POJO once again. On the POJO, I put an annotation saying, OK, this is listening at /WebSocket. Now, I'm receiving the data as JSON, but I may not want to deal with JSON. I may want to deal with my business domain object. So like figure is my business object, and that's the one I may want to deal. So I can additionally specify encoders and decoders here. So if I look at my figure decoder, it says I'm going to decode text. I'm going to give you a figure. This is a decode method which says take a string, return a figure, and I do my business logic of here to take the JSON structure and convert it into my figure object. Okay. Similarly, I have figure encoder, which says it's a text encoder operating on figure. So it takes a figure, returns a string. So now if I look at my endpoint, instead of saying string, I'm saying take the input as a figure, because hey, I've got a string encoder and decoder for that. Because eventually on the wire, what goes is string or text. So this is what makes it happen. But at least in your POJO, you are operating upon using a simple figure object, which is your business object, which is what you created. Okay? So that's sort of a WebSocket way. This is how you create a simple WebSocket application very easily. Now, as you can see, there are a lot of samples here. So I'm not going to show all of them, but something for you to understand is, for example, what I showed you is annotated way of doing WebSocket endpoint. You can also do programmatic WebSocket endpoint. So say, okay, hey, I want a little bit more control over how my WebSocket endpoint is created, what handlers, like text or binary handlers are registered, how the HTTP upgrade is happening. I want to look at the HTTP headers, provide more control on that. So all those capabilities are there. So that's what all of these samples show over here. You also have access to HTTP session. So this particular example will show that. There is also a sample which compares the generation between WebSocket versus REST. So let's see if we can get there actually. So this is what I was talking about. So these are all the headers that are being sent back and forth if you're doing a simple HTTP message, just hello world. So much headers are going back and forth. But if I show you here, so this is a graph where I'm showing number of messages are increasing, keeping a fixed payload of 1,000 bytes. Okay, as the number of messages are increasing, it's showing basically how much time it takes to process that data. As you can see, if I have, so this is 10 messages, so it's a pretty negligent, I don't see any difference to visual eye. Maybe even the computer won't realize it, so that's what it is. But now I see this is for REST, this is for WebSocket. I'm doing 100 message exchanges. That means for each of those 100 messages, I'm generating HTTP headers and I'm consuming those HTTP headers. The moment I go to 500, so it shows how much time it takes in milliseconds. Time is a little bit more visible. 1,000, 5,000, 10,000. So you can see here, for example, the distance is very, very evident. And 10,000 is not that big a number. Now, if you're really building a massively online parallel game, 10,000 concurrent connections is nothing. You're really talking about 50,000, 100,000 parallel concurrent connections. So this is where the difference is evident, why WebSocket versus REST. And by the way, as I said earlier, that you can run over here. There's a payload version and there is a number of messages version. You can play with them, generate your own benchmark if you want to show something.
Sorry, how many sockets can you open at the same time? Do you get a problem if you get close?
Excellent question. So the number of, well, first of all, because you're upgrading from port 80, you don't have to open up a new port on a web server. You still communicate on port 80. WebSocket connection is effectively a TCP connection to your web server, to your application server. So the limit really is the number of file descriptors that are allowed on your application server. So you really have to tune down to your operating system level. Linux by default, I think, or RHEL by default, I think allows 1 billion file descriptors. So it really boils down to how many file descriptors are available. Now, the person who developed the WebSocket implementation for Wildfly, he just ran a random test, and he could easily scale up to 60,000 concurrent connections. That's a good point, actually. So that brings up something.
Can I ask for that?
Yeah, one second. Let me close that one first. TechEmpower.com is a third party which basically run benchmarks on different web frameworks. So this is the one on JSON serialization. And you can see these are the framework numbers. So it's saying basically how many messages are performed per second. Okay? And it says higher is better. It's good. So Undertow is a brand new web server written as part of Wildfly. So here is saying that this is all above Netty, Servlet, Grizzly, all of those containers, so to say, Wicket, all of them. It's above all of them. Node.js is way down here. Tapestry is way down here. Plain Windows. Oh gosh, it's terrible. But the point being, Undertow is right up here, and Undertow is our web server. So with JSON serialization, I think that's what it is. Yeah, best JSON responses per second. There are almost 900 plus thousand requests and responses processed. If you look at plain text. Plain text is actually 4 million plus request responses per second, because JSON serialization takes its toll. So just going to give you an idea on how many concurrent connections we are looking at, and if you're doing JSON serialization, and these are HTTP, by the way. With WebSockets, the number are going to be higher. So I'm hoping that in round 10 or a subsequent round, they can say, oh, by the way, not just data updates and all these things, we're going to add a WebSocket benchmark to it, because that would be very relevant. There's a question somewhere here? Yeah.
Is there any impact in memory, for example, because of session management when you compare it?
So you do the session management by yourself. WebSocket is a stateful protocol, but you maintain the session by yourself. Anything that you have to pass back and forth is bit on your payload. It's a very, very low-level protocol. It really doesn't maintain, all that session management, that the session object I talked about, is automatically maintained by Undertow and Wildfly for you. Any application session information, you have to maintain that on your own. That goes as part of the payload, back and forth between client and server.
Still, even that part that Wildfly has to maintain for you, if you compare it to REST?
To what?
To REST architecture, isn't that, doesn't have a higher impact?
No, well, as I was saying, on a developer machine, we could easily scale up to 60,000 concurrent connections. So we didn't really see. And WebSocket connections are getting into production now only. So we will definitely continue to see, what is the impact of it. Let's see some real world applications who are using it. So the more we see it, the more data point we get. And it's something for me to as well explore as well. So that's something for me to do. I'm giving a workshop actually at DevOps, which is about nuts and bolts of WebSocket. So that's something that I've been planning to do. Are there any implications of this thing? But that's a good data point. Go for it.
Is there any way to determine if one endpoint drops during the session?
No, WebSocket does not provide any reconnection as such. So that reconnection is up to you, once again.
No timeouts, for example, if you try to...
Those are TCP timeouts. So no, that's completely, those are configurable, but again, at the operating system level. It's a very, very low level protocol. As a matter of fact, WebSocket does not even provide request response. It's just one-way message between client to server and server to client. The fact that our API is written, using public string hello world name, because the method is coded like that, under the hood, we send a message from client to server and server to client correlating them, but that's about it. So that way we get request response between WebSocket, but otherwise WebSocket has no such primitive of request response or reconnect or anything like that. Oh, I'm so glad you brought that. How many of you use Internet Explorer as your primary browser? All right, that's okay. You can raise your hand.
I have to.
I get that. I get that. I feel for you, man. I totally feel for you, because you have to. So I go to this website called as caniuse.com. In general, that's a great website because it tells you which browsers are compliant to a particular technology. So here I'm going to caniuse.com/websockets. So you can see, Firefox, Chrome, Safari, the modern browsers, they support WebSocket for a while. IE is a legacy browser. It just started supporting it as well, but the support was not available until IE 9. So if you're using an older version of IE, you don't have support. IE 10, I've heard some bug reports as well. I don't know the Microsoft process. Yes, sir?
We have a nice library called Socket.io that's solving that problem.
Yeah, so, right. Yeah. That was a comment, right?
Yeah.
Yeah, let's make sure. Yeah. So now the important part to recognize about WebSocket is that's not something you can polyfill. In the sense that you can't say, oh, by the way, the browser does not have support for WebSocket, so I'm going to bundle my JavaScript library, which will allow you to do that. Because that support is required in the native browser itself. At least I have not seen such libraries which work out of the box. You can bundle in your WebInf or whatever, your JavaScript library, and that will work. Because that support, it requires all the way down to down connection with your network layer to do that HTTP upgrade and things like that. Okay, so this is in general a good website. So if you go to caniuse.com, it shows you a whole lot of technologies, CSS, HTML5, SVG. You can click on any technology, say offline web applications, and it shows you browser support for each one of them. So generally very good one to use for your clients and figure out. All right, we're going to switch gears then. The second technology that I'm going to talk about today for Java EE7 is batch. What is the use of batch? Well, batch is useful if you want to do bulk processing, like lots of items need to be processed, and you don't want to process them during your peak processing time. Tuesday morning, 11 o'clock. No, that's not a point to do my batch processing. I would rather do it like Sunday morning, 2 a.m. or Saturday midnight or something like that, where hopefully in a bank there is not a flood of traffic at that time, and then I can do my batch processing. So it could be like monthly email statement generation or end of day processing, or think of yourself as running a multiplex theater. You have a lot of multiplexes around the country. You're receiving CSV files from them end of the day, where for their sales data. So you read that file, you process the file, and then you validate it, and then you say, I'm going to store it into a database and then generate a report how much money I made. Okay? So let's see how such a use case can be easily implemented using Java EE7 batch. So Java EE7, well, WebSocket was JSR 356. That's how the specifications evolve. Batch is pretty much borrowed a lot of concepts from Spring Batch, is JSR 352. The entry point to my batch is a job specification language, which in this case is defined as an XML. So I'm saying this is my job XML. So you can see on my line 2, I'm saying it's a job. This job has a simple step, one step basically, but typically your job will have multiple steps with a workflow around them or workflow around them. You're saying this step is of the type chunk. What do you mean that you want to read a chunk of items, process them, then write them, then do the next chunk, then do the next chunk, so on and so forth. And you can define the chunk size, which is by using item count. Within chunk, you have a reader, processor, and writer. Okay, let's take a look at what my reader looks like. So here's my reader. It's just saying except, by the way, it's all standard API, Java, JavaX. So I'm extending the abstract item reader. I got an open method here where I'm reading my data from the CSV file. In this case, it's bundled in the WAR file itself. So here is my data.csv. So I got some names and some dates over there. Now I got a read item method. In the read item, all I'm doing is I'm reading one item at a time. It returns one item at a time. That's all I'm doing, just plain dumb. And when I don't have anything to read, then I return null. That means, okay, no more items to read. Start the termination of the job, basically. Okay, so that's my reader. Whatever item I just read is then passed on to the processor because that's how it's specified in the job XML. That comes over here. So just one method, process item. I validate it. If it's valid, then I return a new person object, which is a JPA entity. So you can take a string, convert it into a JPA entity, return it so that it can be serialized into the database. Or if there is an exception, then you return null. That means, okay, ignore this item. This is not going to be persisted. Now, for each read, you may not have a write. Or even if you have a write, it may not be a most efficient way to deal with it. So what you do is you read, you process, and validate, and you aggregate. Read, validate, aggregate. You aggregate in the writer, and then the writer, you do that chunk item count times, and once you have reached the item count, then you say, now write to the database. So if I look at my item writer here, I got a write items method, which is a list, which is where all my person are stored, and then here I'm just iterating over the list and saying just serialize it. Okay.
Is the library not typed?
It's not generified, no.
Why not?
I wish it was. The JSR 352 specification version 0.8 actually had generics into them. When the IBM, because this is IBM's implementation, or at least this is Red Hat's implementation, but when because IBM was a spec lead for this, they had to get a reference implementation out. They couldn't figure out how to get generics working in the implementation, so conveniently they pulled out the feature. They said, let's go 1.0 without generics. So hopefully 1.1 or subsequent version will have generic support. I personally love the generic support. My initial samples were, if you look at the GitHub history, you'll see initial samples actually had generics in them. Let's say I'm using 100,000 records. My item count is say 100. So I'm reading 100 items. Well, I'm reading one item, validating it, aggregating it, and writing all those 100 items out when the item is aggregated together. But the important part to understand is that's all done within a container managed transaction. The container automatically starts a transaction before the chunk is started and automatically commits it when the chunk is finished. And then it starts again for the next item. That's automatically managed by the container itself, nothing that you need to do. So the advantage of that is there is checkpointing and all that fun things that are available to you. So you can say, I was reading 100,000 records. I read 50,000, but the job failed now. Resume the job, but resuming the job means it's going to start from 50,001, not 0, because there is automatic checkpointing. And all of this data is actually stored in an underlying database. So in case of Wildfly, for example, we ship with the H2 in-memory database. It stores over there. But that's OK. For development, that's fine. But you can easily change the batch subsystem to say, point to a JDBC database, like my MySQL or some other database which is stored on which is a persistent database. So you can actually have information about it. So those log tables, the schema for them is not defined by the spec. but it's available to you, so you can look at the database schema and build your fancy tools on top of that. Now, when EAP7, which is a commercial version of Wildfly, goes live, we will have some tools as part of the JBoss admin console, which will allow you to kind of look at that data and say, oh, this job terminated. It terminated at 50,000 record, and this was the error. OK, restart this job. And the job will automatically know where to start from, so that you don't have to worry about it. Oh, do I care about which record it starts from? No. OK, so that's the basic job. Yes, sir?
Is it cluster aware?
It is not cluster aware. Not yet, not at this point of time. I will show you some ways by which you can sort of pseudo make it cluster aware. So let me get into that. So let's say you're running on a multi-core machine. You are having 100,000 records to read. You want to leverage each core to read half of it. So you can do that very easily, declaratively and programmatically. So here, I got a same thing, job, step, chunk, item count, 3, simple, but to my reader, I'm specifying start and end properties. And down here, I'm saying, oh, this is partition. And this partition has 2. The partition plan says 2 partitions, partition 0, partition 1, start value, end value, start value, end value. So now this job is running on multiple cores, is being double more effective. So that's what we have. This is declarative. You can do this programmatically as well, where you can say, oh, go figure out at runtime how many cores, etc. is there, and then create the plan for you. Of course, your reader has to be updated to understand those properties, but that injection is just using CDI. Here's a little bit more elaborate example. You can also define flows where you're saying, oh, this flow has 2 steps. I want these 2 steps to execute. Then I want to go to the next step or next flow. So you can start defining your logical arrangement of how the steps need to be executed, sort of a pseudo workflow that, oh, once you're done with this flow, next is step 3. Step 3 is over here. So execute that. And in this case, I'm using batchlet, which is not chunk, but batchlet is basically an ad hoc task. Load a file or send an email or things like that. Okay? But one of the questions that people typically ask is, how do I schedule my batch job so that it automatically runs at the end of the day? So the recommended model is batch API by itself does not have a scheduling API, but Java EE has. So you can trigger it from an EJB, for example, a singleton or a stateless EJB. Then you can put the add schedule annotation with the cron syntax that, oh, trigger it at every end of the day. And then from that method, you can say, oh, go start my job, things like that. So those can be very easily enabled.
Is the implementation available as a separate library?
It is. It is. So let's take a look at that.
So this means we could use it on E6?
Yes. Yes. It's funny you asked that. There were some people who are actually using it on EAP6 today. So you look at JBarrett. JBarrett is the batch implementation by Red Hat. It's in a GitHub project. So look at JSR 352. And you can just literally check out the entire workspace, build it. And it's not a supported configuration on EAP6, but yes, it's available. That's one part. Second part is, if you want to use it in a Java SE environment, that's possible too. So you don't really need a Java EE container to run it. I just want to do my batch jobs. Yeah, you can do that too. Any questions on batch?
Where is the comparison with the Spring data and the batch?
It's very similar to Spring Batch, actually, because Spring, in the past 16 years, for the first time, VMware actually contributed to the JSR 352. They were part of the expert group. You will see most of the syntax is actually borrowed from there.
Okay,
So it's literally 95% similar. So here is Spring Batch and JSR 352 differences. This is about a year-old blog. So you can see here, it talks about the terminology. So it says job, step, chunk, item, how the class names are different. So this blog kind of highlights, even the job description is pretty similar. Here they say tasklet, we say job, step, chunk, which is natural because Spring Batch has been existing into so long, you can't just randomly change it. But because it has been existing into so long, so we have had some excellent implementation experience over there, so we could simplify it as part of the Java EE7. But this blog at least talks about, so the way you do that is you go to Delicious, Arun Gupta, say batch, Arun underscore Gupta. And the second link over there, it talks about comparison between the two. But pretty much, what I'm hearing from people who are doing it, I think it even says it here. So this is the diagram which is from Spring Batch, which is in the JSR 352 specification. It's a pretty detailed article. It talks about it. So here you go. It doesn't give a number. But I thought somewhere I saw a number that they're 95% similar, very 5% minor changes only. Okay. So the next one that I'm going to go with is JSON API. Okay. So JSON is again a brand new API as part of the Java EE7 platform. What that gives you is the ability to do JSON processing as part of the Java EE7 platform. So by processing, I mean either consumption or generation. Now, as part of the JSON processing API, if you go to the XML LAN in Java, there is a JAX-P, which is a lower level API, or a JAX-B, which is a higher level API. So JSON processing in Java EE7 is more like JAX-P. It's a lower level API. Okay. So now with that, JAX-P also has two APIs. One is a object model API or DOM, or a streaming API, which is stacks. So those two APIs, the JSON-P has two APIs as well. So it can say, oh, I want to deal with the object model. That means read the entire thing into memory, and I want to manipulate it, or just throw me events, and I'll let you know what event I want to deal with. Okay. So let's take a look at some of those examples. So here I'm saying from the JSON as a static class, I'm saying create a reader, and I'm giving it an empty array. And I say JSON reader.read object. I get a JSON object. Okay, and this is my assert statement, because remember I said these are Orkelian tests as well. Now I can say JSON.create reader, apple red, banana yellow. So this is just two name value pairs in my JSON object. And then I can read it as an object, and then I assert on them. Now I can start it as an array because of the square bracket here. One element apple red, another element banana yellow, and close the array. But now I'm reading it as an array. I'm saying JSON reader.read array. Or if need be, I can make a little bit more elaborate structure, name value, named arrays, and things like that, and I can read it as a structure. The thing being, JSON object has the entire representation available into it, and you can dig into the API to find out what element you care about. So that's that. On the other side, here I just have the same empty element, but I'm saying create the parser. So I'm creating a JSON parser, because the parser is going to generate the event. And let's see what events are being generated for me. So I'm saying start object, end object. That's it. Just two simple objects, simple events. In this case, if I walk you through it, start object, key name, value string, key name, value string, end object. So those are the events that are being generated for you. You can say, I just want to switch on a particular event and then do the processing that I need to. Say, for example, at one particular, when I see this particular key name, then I want to read the value, otherwise just keep reading. Here I'm saying, for example, start array, start object, key name, value string, end object, so on and so forth. So these are all the events that are being generated for you. So this is a standard way to consume JSON, again a much lower level API. As part of Java EE8, the new JSR has been filed to say JSON binding JSR. So you could say on a POJO, put annotation, and this will automatically do the conversion for you. So you don't have to worry about what's this low level parsing. Just let me deal with the business objects. Now we see where our customers are using it is, so they've been bundling Jackson and other libraries as part of the WAR file. But the refactoring from Java EE6 to 7 is, okay, I want to get rid of the library now. I don't want to use Jackson, for example, or some other library, because I can use it. If I'm deploying my application on Wildfly, it already has the implementation, I might as well use it. So that's the way typically they're using it. So here I'm saying JSON.create object builder build. And all it's giving me is an empty object, okay? Now, here you go. JSON create object builder, add name value build. Then I can say, this is a separate method, of course, JSON.create array builder, create object builder, and so that is possible, yeah. So let me talk about 2 more technologies I'm going to talk about that I've been told, and I'm willing to talk about others later. But JAX-RS and CDI, those are the 2 more technologies I'm going to talk about. JAX-RS is a standard way of doing RESTful web services, okay? In JAX-RS 1.1, the goal was have a POJO. On a POJO, you put annotations, and that POJO would be published as a REST endpoint, and you can call it using your HTTP GET, PUT, POST, DELETE, head, options, all of those standard HTTP methods. In JAX-RS 2.0, one of the primary focus has been to add a brand new client API. So let's take a look at how that looks. So I'm saying this resource is available at path. It's a request scope resource. This is the method which is called when I access it using HTTP GET. It produces application XML, application JSON, and I return a person array, and that's it. So all the serialization, deserialization is under the hood. So if I look at, say, person bean here, I just put XML root element annotation. It automatically, JAX-B takes care of serializing it into XML and JSON, or at least XML. JSON is implementation specific. I can start adding sub-resources, but that's more like JAX-RS 1.1. I'm not even talking about JAX-RS 2.0 yet. But in terms of JAX-RS 2.0, client builder is a brand new API introduced in JAX-RS 2.0, which says this is sort of my entry point to the client API. So I'm going to say build a new client, give me a client builder, give me a new client instance, because on that client, I'm going to specify the target, which is the URI, which is going to get invoked. So now here, I want to post a request as if I'm emulating an HTML form. So HTML form, if you think about it, is a multi-valued hash map. Name value, that's what is going over the wire. So I'm going to create a brand new structure called as multi-valued hash map. In the hash map, I start adding name value. So name, age, so on. And then on the target, which was created earlier, right here, I'm saying build a request and post it, and the content being the form. So very clean, fluent builder style API where you say, okay, target, request, post, and go for it. So you clear the map, one more name, a couple of more name values, post it again. Clear the map, couple of more name values, and post. And the same way you can do get also. Target, request, get, and just give me the person array. I don't care about what's on the wire format, you figure it out. So that's something cool. So that's a brand new client API introduced. The advantage it gives you is how you can invoke a Java endpoint in a standard way. So that's one addition to JAX-RS. Another big addition to JAX-RS is how, if you're doing a REST call, server is blocked and the client is blocked. It's a synchronous call, right? So it's blocked, both are blocked. So JAX-RS is used so widely, we added support for asynchrony on the server side and asynchrony on the client side. So in terms of asynchrony on the server side, you can say, oh, I know this method is going to take longer, a few seconds, and maybe it waits for some resources forever. But I don't want to block my thread. So you say, okay, you know what? As soon as a request comes in, I'm going to mark it as suspended, and I'm going to dispatch a new thread where the request processing is going to happen. And when the request is processed, then it's going to return the result back to me. And then I will respond back to the client. So at least the server thread is not blocked. You have spin up a new user thread where all the processing logic is happening. And then you can resume and return the result back to the client. So that's more like server-side asynchronous processing. Then you have a client-side asynchronous processing. So for example, here, I build the request. I can add this simple async method in here. At the moment I say async, that means now it's going to give me not a string or whatever type I specified. It's going to give me a future of that string. Future is my JDK concurrency API. So I say what? Future.get, future.post, future.cancel, not post, but future.get or cancel or wait, and things like that. So that way it gives you client asynchrony. Important part to understand is, if you are doing client asynchrony, so client is asynchronous, but server is still blocked server. Or if you're doing server-side asynchrony, client is still synchronous because client is still blocked. So you might have freed up a server-side thread. So in order to build scalable application, if you're using Java API, it's recommended to use both client-side asynchrony and server-side asynchrony. That way, you can scale much better. Something else that is added to JAX-RS is also like filters and entity interceptors. So think about filters as targeted towards logging your HTTP headers. And entity interceptors are targeted towards manipulating your HTTP payload. So let's say you look at the HTTP headers, you recognize the body is gzip, and you recognize on your server side or client side you can't handle gzip. Then on the fly you can throw a gzip interceptor, which will automatically know how to gzip and ungzip it, and that's the way you play around. And the reason they're kept separate is because headers are anyway on the wire, so you know what's happening. But the payload may not be on the wire and may trigger some data processing. Because effectively payload is generated by invoking the business method. So let's say, think of a request that is coming in or the response that is going out. If you look at the payload, you may have triggered some business processing. So if you have triggered the business processing, that may be an extra load which you may not want to incur. You may just want to deal with the HTTP headers only. So in which case you go with filters, but if you want to do a body play around with the HTTP body or payload, then you do entity interceptors. So the last thing I'm going to talk about is CDI. CDI is context and dependency injection. It basically gives you the ability to do inversion of control. So instead of saying create a new user transaction and manage the transaction lifecycle yourself, because I don't care about all those details. Container, give me a transaction. You manage the transaction. So you can just say @inject user transaction. The container will inject the user transaction object for you. It will manage the lifecycle for it. And then when you're not using it, the container will automatically collect it back. Much easier. Using @inject, you can inject the user transaction. CDI 1.1 also allows you to inject a lot of other objects. So you can say servlet context you can inject. You can just say in any servlet @inject servlet context and things like that. You know what? Let me actually pull up a presentation which will give you more details. Hold on. So it's basically a type-safe approach to dependency injection. Because if you look at Spring, a lot of it is about put it into the deployment descriptor, string based. So you figure out your dependency is resolved or not at the runtime. Here is type safe, so you figure it out much earlier in the cycle itself. So it's type safe approach. It defines well-defined life cycle for stateful objects. So you can say it's a request scope object, or it's an application scoped object. It's a transaction scoped object. It's a conversation scope object. So it basically says it ties a bean life cycle to that scope. That means if you try to access the bean in the scope, it will be available. If you try to access outside the scope, it won't be available. It strongly looks at strong typing and loose coupling. Those are the key concepts over here. I'll talk about them a little bit here. But the idea is you can say exactly that this is the type I want without specifying how you get it. The CDI runtime automatically figures out, okay, this is where I'm gonna get it because I understand the context and the scope. If the bean doesn't exist in that context and scope, I'm gonna create a new bean and keep it ready in the pool so that if next time somebody asks me in the same context and scope, I give the same bean instance. Otherwise, you'll have to manage the context and scope yourself. There are a lot of cool things in CDI in general. So let's see this. This is how CDI really works. You can do the injection in field, in method, and in constructor. And there are two things that you need to specify, type and qualifiers. So let's see this. Greeting is an interface. I just want to inject this. So I say inject, @inject greeting. Now, what kind of greeting I want to inject? So I say simple greeting. Simple is what we call as a qualifier. So you can have multiple implementations of greeting. One of them could be qualified with @simple. So you're saying just inject that greeting here. So you are requesting injection using @inject. What type is the greeting? and which one is the qualifier. So that's how you define. That's your basic injection syntax. So here I have public interface greeting. It implements greeting. This is the implementation class. And in any Pojo class, I could just say at inject greeting greeting, and it'll inject it. And I can say greeting.greet. Now, this simple or greeting could have multiple implementations as well, in which case one of them needs to be qualified, simple, fancy, whatever it is. So here. So I could define a new qualifier, say fancy. And then I define fancy greeting, which is saying, which again implements greeting here. Hello, my mouse. And I qualify this with @fancy. Now I can say inject fancy greeting. Now if the interface has multiple implementations, it'll say, I need to clearly identify which implementation you want me to inject. And that's the type-safe approach of doing it. So if I can walk you through a little bit of this, it says public interface, simple greeting, fancy greeting. So if I say inject greeting, it says, OK, inject greeting. The fancy greeting has a @fancy qualifier. So by default, I'm going to take simple greeting. So that's going to work. Now I can also say @default, which is a default qualifier in CDI, in which case, again, it'll go back and inject my simple greeting. Now I could say inject any greeting. Any is again a default qualifier in CDI, but then it's saying inject any greeting. I don't care really which greeting is coming, but any would resolve to this and to that as well. So that's where it gets confused. So this won't work. I could say inject any greeting, but fancy greeting. It should be qualified with fancy. Then you're making it specific. So you're really doing your dependency resolution a lot more clearly. You can say any default greeting. Well, this is fancy, this is not default, so this is default. So it injects this particular one for you. And then, of course, you can say inject fancy greeting. So sort of the basic CDI concepts that you need to understand how dependency injection works. I won't go into a full-blown CDI tutorial. But if I go here, now how beans are discovered, that's well, in Java EE6, if you have to have CDI, you have to add a file called as beans.xml. That was the biggest source of error, because people were saying, oh, my DIE is not working. Why? There is no beans.xml. So now in Java EE7, we made CDI as default. If you don't have beans.xml, what that means is your CDI scoped beans, any bean which has a CDI scope on it, is available for injection by default. So that's where it starts. Okay. If you want to control it, you can control it. So let's take a look at that. So this is a beans.xml, and there's a new attribute added called as bean discovery mode. You could have different values. Here I'm saying all. What that means is all beans in the archive are available for injection. Or you could say none. That means turn off dependency injection. Or you could say annotated, which is the default. In which, excuse me?
It's like Spring.
It's like what?
In Spring, you can use also beans.
Yeah, it's like Spring, but I would like to say it's better. See, I think that's the thing, in general. As I say, some inflation is required for growth. I'm glad Spring is there. That's how Java EE7 is growing. Because Spring is here because of J2EE. And Java EE is here because Spring has done some really cool stuff over there. So we're constantly kind of leapfrogging back and forth in terms of, let's learn from each other and standardize it. I mean, we are standardizing batch in Java EE7 because Spring has done some really cool work over there. So they both are here to stay. Don't think of it as a religious battle. In terms of technically, they are both equally competent. So that's something that has changed in terms of how you can control what level of dependency injection you want. In CDI, you can also have interceptors for your cross-cutting concerns. What was missing in CDI is how do you define the priority of those interceptors? So now, because there was no way to say, you could put it in any order in beans.xml, the implementation might read it in that particular order, but not guaranteed. That's one, but what if you're bundling a jar file which has an interceptor? in which order would that be called? What if there is an extension library that has an interceptor? How would that be called? What if a platform is providing an interceptor? How would that be called? So that global ordering of interceptors was missing. So now CDI has introduced a new annotation called as priority, and using that, you can do global ordering of interceptors very clearly. Okay, so let me show that. So you can define the order in which interceptors are invoked, lower the value, higher the priority. I've never understood why this is so counterintuitive. But platform before is 0, library before is 1000. There are some predefined numbers in the annotation defined for you. So the idea is, on an interceptor, you can say, what is the priority? So okay, I'm saying library before plus 10. But what does that mean further? So interceptors defined by platform specifications should be, if they want to be executed before everything else, that should be their priority range. So those ranges are defined. If the platform specifications, they should be executed after all the interceptors have been done, then they should be in that range, basically higher than platform after range. Extension library before and after an application. So there are very clearly defined ranges now. We think 1000 is a pretty big number. Hopefully you don't have an application with 1000 interceptors in there. But the 1000 still gives you a big range on how you can define the values and in which order they need to be invoked. So there's a global ordering for interceptors that is available as part of CDI now. Any other questions? Any other question on Java EE7 or Wildfly or anything?
Well, I think it's a question that I asked Oracle, but maybe you've heard some things about it.
I no longer work for Oracle, by the way.
All the certification programs for Java EE7?
Well, yeah, that was one of the things I was involved with before I left. I don't know the current status of it. So I don't know the current status of it. Hopefully we'll hear something at Java 1. So you're looking at like Java EE7 developer, architect, those kind of programs?
Still, well, first of all, which one remain, which one have been replaced?
Yeah. No, okay.
I assume that, for instance, the web components, there's a lot of old-fashioned stuff in there, so that
Right.
hasn't been radically replaced.
Right. No, I can definitely fire a mail to my Oracle friends and then find out about that. Yeah. And this is actually the third time I'm hearing this request in the past few days. Yeah. So then something that I want to show you here is, how many of you guys are familiar with OpenShift? Some of you, okay. So OpenShift is Red Hat's PaaS offering, which is basically saying you can run platform as an application service. And the way our classic model works is everything goes in Origin, which is the open source edition, GitHub, everything goes there. Then it goes into public cloud, which is online, which is what I'm going to show you today. Or if you want, it can be installed in your private cloud in your data center called as OpenShift Enterprise. Okay. So in terms of online, it's pretty simple. You log in here. Well, anybody can sign up. If anybody signs up, you automatically get 3 gears. And a gear is 1 gig of disk space and half gig of memory. So you get 3 gear for free, lifetime, no time bombing. Okay, doesn't time bomb at all. But then once I get here, I can add an application. There are lots of applications that you can easily start here. Of course, our product portfolio is here. Jenkins, WordPress. I'm going to start with just simple Wildfly instance here. So you want to start up a Wildfly instance. You set up here. You can say, I want scaling. So it automatically scales with web traffic, automatically configures HA proxy. Everything is completely magical to you. And then I say create application. So once I create an application, it creates the application for me. It even creates a Git repo for me. So I can Git clone it on my directory. And the programming model is, I make changes, I add source code over there, git commit, git push. You git push, and the application is deployed to you live. So very simple, very intuitive programming model. With full integration with JBoss Developer Studio, which is our Eclipse-based tooling, and IntelliJ as well. So IntelliJ provides that tooling. This tooling does not exist in NetBeans as of today. So now if I go here, say openshift.com, log in a separate tab, you see my application is automatically created. It was still spinning over there because it's trying to resolve, what is the DNS name, propagation, etc. But my application is automatically created now. So if I go to the app, so here I have my source code. I can close my Wildfly here. So now I can say git clone the repo. Okay. So it's cloning the repo now. It's still not propagated. Still the DNS names are getting propagated across the different servers. But once that is done, then I can literally git clone the repo. And then git commit push will just work as is. Any other questions around Java EE7?
Is there still any use case to use SOAP in a new project?
Generally not. Generally not. No, I mean, honest about it. Typically, where I'm seeing, so I'll share a use case with you. So I know somebody who's building a Java EE7 application for UNHCR, which is UN, United Nations, something with refugees. HCR is R is refugees. I know. So their interface is only published using SOAP. They've not migrated. They're not publishing a REST or a other interface there yet. So when they're building their this is a Java EE7 application running on Glassfish, but they had to use JAX-WS API to talk to them using SOAP. So think of it as more as a integration with legacy applications. But if you are building your own applications, there is no reason or need to expose SOAP unless your clients are only capable of consuming SOAP.
Yeah. Could you give an argument why? Because I still hear people say, yeah, but with SOAP we can do more complex stuff, or other nonsense arguments, but it's really difficult to persuade people not to use it.
So ask them what nonsense stuff they can do. And ask them, tell me what is it that you can do with SOAP. Well, see, think about this.
They think REST will get really complicated if you want to do more functionality. You
See,
can argue whether you want to get complicated.
Yeah. So SOAP has a place in the sense, that's the reason called as a Death Star. It's WS star rather. It has a bunch of WS star specifications. So for example, in order to do a brokered relationship, in SOAP, in REST is very tricky. You have to build something on your own because you have to build that protocol on it. As a matter of fact, in SOAP, there is something called as WS trust. So that WS trust exactly define how a brokered relationship would be established between multiple parties. So that's one reason, for example, you want to use SOAP. If you want to, I'm forgetting, you can do WS reliable messaging, for example, if you want to do reliable messaging over the wire using SOAP. So that's where you can use it. Although I have not heard a lot of people using that actively for new projects, SOAP is, the problem with SOAP typically is not getting complicated, but the problem with SOAP is the processing cost that is involved. Because, see, SOAP is a protocol, and it's on the wire stuff as well. So there's a lot of cost associated with SOAP header processing. So that's where it gets complicated, which is not the cost associated with REST. And it's a sort of a, I wouldn't call it as a vicious cycle, but that's a normal cycle. Go back many years ago, Corva was very prevalent, then SOAP became prevalent, then REST became prevalent. Now WebSocket is catching up. Tomorrow something else will come up. But as a consulting company, as a customer, you have to support sort of those legacy technologies. I don't know for how long, but that's the nature of it. But in new projects, generally, I don't see it. I would love to get involved in those discussions if people say I can do some fancy stuff with SOAP and not with REST. This is purely project driven. Let's not go with the mindset, no, Rastafarian is the way to go. Not necessary. So let's go with the open mindset. Let's understand what is it that you're trying to solve. And if SOAP is the only way, let's go SOAP way then. But then be aware in terms of the skill set that you will get for doing SOAP programming. It is a complex setup. It is a complex setup. It is a very complex setup. Setting up, I've done this. A few years ago, I was involved with Microsoft pretty heavily in doing interoperability testing when we were building our web services toolkit at Sun. Literally debugging WSDL, your SOAP messages, on the wire messages, looking at your broader, how the SOAP header processing look like. Why is this not looking correctly? It was pretty tedious. And then setting up your SAML assertions across the network, and it's not easy. Harry. So here my application is ready now. So I can go to the application overview page, for example. And now my application is live. Now if I do git clone, it's ready here. So I can say source, well, let's see this. What all is here? So there's a bunch of stuff here. So I got an index.html. Let's look for the body tag here. So all I'm going to do is add Netherlands. I added here. I made a change and I push it, and that's it. That's literally what I need to do to push a change to OpenShift. And now it's going to restart it's stopping my Wildfly instance, restarting it, and the changes are going to be live here. So this is how I do in JMS 1.1. Okay. So I look up a resource. I look up a connection factory, look up a destination, do lots of boilerplate code. Connection, session, message producer, text. I only want to do this message producer.send. That's my intent. Then it is a lot more boilerplate code, catch a checked exception, close the connection, which again throws a checked exception. Most of the time when you're catching a checked exception, you say, nah, I don't care, just push it up, not my problem. So you just propagate the exception, or you just do this silly print stack trace which does nothing. So let's see how the API has evolved in JMS 2.0. So this is like line 48 to 28. It's about 20 lines of code. That is converted to 1 line of code here. So JMS context is my entry point to the JMS 2 simplified API. All I say is context, create a producer, send the message to the destination and the payload. So in specific improvements, everything is a runtime exception. JMS context is an entry point to create your producer and consumer. No boilerplate required, and a very clean builder API.
I know this API. I was wondering if there were any changes in the message-driven beans with regards to when there are errors and...
The MDBs, yeah, the MDBs are going to be impacted. There was a fundamental change required in JMS for MDBs to be improved. That fundamental change was introduced late in Java EE7. So now MDBs are likely going to be changed as part of Java EE8. That is already on the roadmap.
It's on EE8?
EE8.
Oh, okay, so
Yeah,
I was
yeah.
wondering if there were any
Right,
changes on that.
right. EE8.
Okay.
Yeah. All right. Thank you very much. You can reach out to me at arungupta@redhat.com or arungupta@gmail.com. Thank you.